Hello guys, welcome back. Today's story, cloud computing. What is cloud computing? Cloud computing basics, advantages, benefits of cloud computing, characteristics of cloud computing, future of cloud computing, and how to become a successful cloud engineer. Let's go. Cloud computing is a technology that allows users to access computing resource services over the internet such as servers, storage, databases, software, and analytics. Cloud computing has many advantages and benefits for businesses and individuals, such as cost reduction. Cloud computing eliminates the need to buy and maintain expensive hardware and software and pay for electricity and cooling costs. Users only pay for the services they use, which can lower their operating costs and increase their efficiency. Scalability. Cloud computing can provide users with the right amount of resources they need when they need them and from the right location. Users can easily scale up or down the resources according to the demand without worrying about capacity, planning, or performance issues. Productivity. Cloud computing can improve the productivity of users by allowing them to access their data and applications from anywhere, at any time, and on any device. Users can also collaborate more easily with others by sharing and editing files in the cloud. Performance. Cloud computing can offer users high performance by using a network of secure and reliable data centers that are constantly updated with the latest and fastest computing hardware. Users can benefit from reduced network latency and faster data transfer speeds. Reliability. Cloud computing can enhance the reliability of users' data and applications by providing backup, disaster recovery, and business continuity solutions. Users can store their data in multiple redundant locations on the cloud provider's network, which can protect them from data loss or downtime. Security. Cloud computing can strengthen the security of users' data and applications by using a set of policies, technologies, and controls that are designed to prevent the unauthorized access, attacks, or threats. Users can also encrypt their data, use firewalls, and manage their access rights in the cloud. There are many cloud providers that offer different types of cloud computing services, such as Amazon Web Services (AWS), Microsoft Azure, Google Cloud Platform (GCP), IBM Cloud, Oracle Cloud, etc. These providers have different features, pricing, and support options that our users can choose from according to their needs and preferences. Some of the characteristics of cloud computing are on-demand self-service. Users can provision and release cloud resources as needed without requiring human intervention from the provider. Broad network access. Users can access cloud resources over the internet using standard protocol devices such as laptops, smartphones, tablets, etc. Resource pooling. The provider's resources are pooled together to serve multiple users simultaneously using a multi-tenant model that assigns resources dynamically according to user demand. Rapid elasticity. Users can quickly scale up or down their cloud resources according to their changing needs without affecting the performance or quality of service. Measured service. Users can monitor and control their cloud resource usage and costs using metrics and tools provided by the provider. Cloud computing service models. Cloud computing service models are the different ways of delivering cloud services to users over the internet. There are three main types of cloud services models, such as software as a service (SaaS), platform as a service (PaaS), and infrastructure as a service (IaaS). Each model has its own characteristics, advantages, and disadvantages. Software as a service (SaaS) is a model where the cloud provider offers software applications that users can access through a web browser or an online app. The cloud provider manages the software, including its installation, maintenance, updates, and security. Users can only pay for the software they use without having to worry about the underlying infrastructure or platform. Some examples of SaaS are Google Apps, Salesforce, Dropbox, and Slack. Provides software applications accessible through web browser or online app. Managed by cloud provider. Pay-per-use. High level of abstraction. Platform as a service (PaaS) is a model where the cloud provider offers a platform that users can use to develop, test, run, and manage their own applications. The cloud provider manages the platform, including its services storage, databases, and operating systems and tools. Users can only pay for the platform they use without having to worry about the underlying infrastructure. Some examples of PaaS are AWS, Elastic Beanstalk, Azure App Service, Heroku, and Google App Engine. High level of abstraction. Accessible through programming languages or tools. Managed by cloud provider. Pay per use. Medium level of abstraction. Infrastructure as a service IaaS is a model where the cloud provider offers infrastructure resources that users can use to create their own platforms or applications. The cloud provider manages the infrastructure including its hardware, networking, and software. Users can only pay for the infrastructure they use and have more control and flexibility over it. Some examples of IaaS are AWS, EC2, Azure Virtual Machines, Google Compute Engine, and DigitalOcean. Provides infrastructure resources. Accessible through virtual machines or APIs. Managed by user. Pay per use. Low level of abstraction. The future of cloud computing is bright and promising as more and more businesses individuals are adopting this technology for its various benefits. Some of the trends and innovations that are shaping the future of cloud computing are artificial intelligence, AI and machine learning, ML, and cloud providers are integrating AI and ML capabilities into the cloud services which can help users analyze large amounts of data, automate tasks, optimize processes, enhance customer experience, etc. Internet of Things IoT cloud providers are enabling users to connect and manage their own IoT devices in the cloud, which can generate valuable insights, improve efficiency, and reduce costs, etc. Edge computing cloud providers are extending their cloud services to the edge of the network, which can provide users with faster response times, lower bandwidth consumption, better security, etc. Hybrid color cloud providers are offering users the flexibility to combine the public cloud services with their private cloud or on premises of infrastructure, which can provide them with more control, customization, and compliance, etc. Serverless computing cloud providers are allowing users to run their code in the cloud without managing any services or infrastructure, which can provide them with more scalability, simplicity, cost effectiveness, and etc. To become a successful cloud engineer, one needs to have a combination of technical skills and soft skills that are relevant to the field of cloud computing. Some of the technical skills that a cloud engineer should have are programming languages. A cloud engineer should be proficient in one or more programming languages that are commonly used for developing cloud applications or scripts. Some examples are Python, Java, JavaScript, or C, Ruby, PHP, Go, etc. Cloud platforms. A cloud engineer should be familiar with one or more cloud platforms that offers various types of cloud services. Some examples are AWS, Azure, GCP, IBM, Cloud, Oracle, Cloud, etc. Cloud services. A cloud engineer should be able to use different types of cloud services that perform different functions in the cloud. Some examples are compute, storage, database, networking, security, analytics, AIS, ML, IoT, etc. Cloud tools. A cloud engineer should be able to use different types of tools that help in managing or optimizing cloud resources or applications. Some examples are AWS CLI, Azure CLI, GCP, SDK, Terraform, Ansible, Docker, Kubernetes, etc. Some of the soft skills that a cloud engineer should have are communication. A cloud engineer should be able to communicate effectively with different stakeholders such as clients, managers, team members, etc. A cloud engineer should be able to explain technical concepts in simple terms, write clear documentation, give presentations, etc. Problem solving. A cloud engineer should be able to identify and solve problems that arise in the cloud environment, such as performance issues, security breaches, configuration errors, etc. A cloud engineer should be able to troubleshoot, debug, test, and optimize cloud solutions. Creativity. A cloud engineer should be able to think creatively and innovatively to design and implement cloud solutions that meet the user's needs and expectations. A cloud engineer should be able to explore new possibilities and opportunities in the domain. Learning. A cloud engineer should be able to learn continuously and keep up with the latest trends and developments in the cloud industry. A cloud engineer should be able to acquire new skills and knowledge that are relevant to the cloud domain. Thanks for watching. Subscribe for more informative videos.